Alright, here we go again. Question 5 or part 3 of our video. We're probably about halfway through, so this could be quite a few quite a few videos here. However, I think it'd be really good that you can go over it again and again and again. It says insulin is a protein that is involved in the body's process of glucose. Part of the structure is shown below. Alright, again, it's a big structure. So what are we looking for? We are looking for functional groups. So I can see here I have an amide group. Before I even answer a question, I can see an amide group here. I can see one there, I can see one there. No other functional groups. So I'm thinking to myself, it's going to be something to do with, you know, proteins, drawing the monomers, all right, or it could be hydrolysis reaction of some type. Before I even read the question, however, it says on the diagram, circle an amide link. Well, here we go. You've got two. You could circle one or two. It doesn't matter which one. It says draw the structure of one amino acid that makes up insulin. Well, I'm going to get rid of everything else just so we can look at it. So to find our amino acids, break your amide links. So if I break one there, and there's another one that I have here that I can break. Alright, so I can see that I have two amino acids here. I have this one here, and I have this one here if you wanted to draw that one in. So drawing one of them, I have NH2. Alright, here's my carbon, which I'm just going to call CH, and then COOH for my carboxylic acid, and then I'm just going to draw the rest of the chain on there. So we've got CH3, CH2, CH, CH3. So there you go, there's one, or I could have drawn the other one, H2, N, CH, COOH, which is just that top part there, and then draw the structure down here, so CH, CH3, CH3, which just covers along here. Alright, so there are my amino acids. Draw the product when the amino acid that you've drawn self-ionizes. So again, all we're doing is taking our H and chucking on our nitrogen there. We're drawing the zwitterons. Alright, so I'm just going to copy and paste, so just bear with me while I do that. I'm going to move that down to here. Alright, or my other one, for instance. Move that down to there and just tidy it up a bit. Alright, so you're going to lose the H off the end here, and those H's are just going to come up here as H pluses. Okay, again, there's my zwitteron forms. Alright, it says here a protein's shape is vital to its function. Outline how the pH, change in pH will affect the structure and form of a protein. It denatures it. Alright, it's worth 3 marks. So you would get one mark for saying denaturing, and then 2 marks of explanation. Alright, so what happens when the pH is greater than 7 and what happens when the pH is less than 7? Well, if it's greater than 7, we're going to have, if it's greater than 7, it's going to be basic. So we're going to lose, we're just basically going to have a H2N and a COO minus. Okay, we're not going to have any H pluses on there because they're ready to accept them, which makes them basic. And if there's a pH which is greater than 7, we're going to have all of our as many H pluses as we can on here. Alright, so let me use this one as an example, and I'll just, here's my zwitteron here. Let's chuck it here. So if we look here, if we look at it and we put a pH greater than 7, so we make it basic, that's what it will look like. Okay, I'll still have my minus up here. It's ready to accept H pluses. Alright, and if it's a pH less than 7, well, you guessed it, if it's a pH less than 7, it's going to be acidic, it's going to have heaps of hydrogen, so I'm going to have a hydrogen there, and I'm going to have a hydrogen there, okay, and put my plus up there. So I'm ready to donate. Now notice with the overload of hydrogens, it can't then go on to react further, okay, like it would in our normal chain structure here, okay, because I've got the H's with a H plus and nothing negative to attach it to. That's going to sort of stay on its own. and a pH less than 7. Again, I've got no H pluses to attach it to, so it's not going to form my amide links. All right. It says here, discuss the effect of raising the temperature of a protein well above its optimum temperature. Again, we denature it. All right, so we change the shape. All right, and if we change the shape, then the protein can't engage with the active site. Okay, so there are your 3 marks there. Then goes and say maltose is a disaccharide formed by the condensation reaction between 2 glucose molecules. So here we've got 2 glucose ring structures here. It says the structure of maltose is shown below. It says maltose can be divided into 2 glucose molecules. Name this type of reaction. Well, if we've got condensation goes one way, what goes back the other way? You guessed it, hydrolysis. Okay, hydrolysis is where we add water back to this here to split it so that we get an OH here and an OH here, all right, and no oxygen down there, all right. So as you can see, H2O, I've got 1, 2 hydrogens there, 1, 2 hydrogens there. My oxygen comes there, and this other oxygen comes from the fact that I had an O down here. Alright, so that should help you there. If you one way is condensation, the other way is hydrolysis. 1 mark, 3 lines, wow. Alright, question 6 goes on to say use the structures shown in the table to answer the following questions. Alright, so we've got some fatty acids here. This wasn't in the test. I think I ended up leaving it out only because when I photocopied the test I ran out of paper and I just took it out of the photocopy without even thinking. Alright, so I've got 3 fatty acids here. It says draw the structural form of the triglyceride that is made from C. So if I just use this one here and I use my triglyceride, well, remember it has a propane backbone, so CH2, CH2, and it is it's an esterification reaction, so I'm going to put a C, O, O in this case, and we're going to have, sorry, I've drawn that the wrong way. We're going to have an O, C, O, and then which comes from there, and so there's the rest of the molecule there. So CH2, 16, CH3, and we're going to get that 3 times. Okay, and again, you don't have to put the brackets in around a CH3. I've just done it because I'm just starting to get tired as it's 12:45 in the morning. Okay, so here's the structural formula of the triglyceride that is made from form C. So name the functional group that is common to all triglycerides. Well, let's look at it. We've got that one, and that one. So what's the functional group? It's an ester. All right. It then goes on and says a simple chemical reaction that distinguishes between A and B involves the use of a burette filled with sodium with a solution of bromine in an organic solvent. All right. Briefly on who you would distinguish between the two, or that should be how, using a burette filled with a solution of bromine in an organic solvent. All right. So let's look at this here. If we have a look here, I have bromine water means what? What does bromine? If we're looking with bromine water, what are we looking for? Okay, that is to test, that's a test for unsaturation. Okay, so we're looking for double bonds. Alright, so how would I know both A and B have a double bond? Alright, so how would I distinguish them apart? Well, let's count the double bonds. A has 2 double bonds and B has 1 double bond. Alright, so when I add bromine water to these, I would have more bromine water react with this one. Okay, because I have twice as many double bonds as this one, so I would have less bromine water. So using a burette, alright, you just almost do a titration. Alright, so you do a titration where you've got your bromine water in here, and down here you've got your fatty acid. Okay, it's dissolved in an organic solvent. So you run your burette through here, all right, and if you ran it through your second one here, whichever one used more, okay, whichever one used more bromine water would be the one with a high degree of saturation. Okay, again, let me make that clear to you. 2 double bonds in A, 1 double bond in B, so therefore if I have 2 double bonds in A, then I can actually get, okay, if I just take these out, if I have 2 double bonds in A and I react them with bromine water, well, I'm going to have 1, 2, 3, 4 lots, so 2 moles of bromine, because it's Br2, will react with every 1 mole of this, whereas only 1 mole will react with this. So as you can see here, A would need more bromine water than what B would. Alright, so you just run a titration. Okay, it says state how edible oils differ from fats in terms of their origin. Well, edible oils will come from plants, or they'll come from marine animals. Alright, and fats, edible fats come from land animals. Okay, in their structure, well, we know the oils, okay, lots of double bonds or unsaturated. All right, whereas fats are saturated or contained very few double bonds. Sorry for mixing that up by what I've put in the brackets each time. So yeah, all right, margarine. Now we spoke about margarine, what it was and how it was the origins of it. But anyhow, have a look here. It says margarine is produced from vegetable oil by a process known as hydrogenation. State the reaction conditions and reactants required for the reaction. Well, hydrogenation is the adding of hydrogen, so we need hydrogen. Okay, we need the oil. State the reaction conditions and reactants. So hydrogen in the oil, and we need heat. Pressure is generally good too to increase rate. And we need a nickel catalyst. Nickel catalyst. Let's get that right, make it a bit neater. Nickel catalyst. Alright, so there's your 2 marks there. Explain one change in the physical properties of vegetable oils upon hydrogenation. Well, if vegetable oil is an oil, when I hydrogenate it, it will convert it to a, if it's an oil which is a liquid, when I hydrogenate it, it's going to convert it to a solid. All right, hence why margarine is spreadable. All right, so that's the end of it. That's the end of that test there. I consider that a fairly easy test. However, looking the way some of you did it would tell me otherwise. Again, the key to this is making sure that when you see structures, find out what their functional groups are and then just go over what the tests are for those functional groups or those different reactions, all right? So if you do have any further problems with this stuff, please come and see me. Have a chat at some time. Again, don't be afraid to look over the video over and over again, see how that goes for you. But apart from that, guys, again, if you are struggling, come and see me. We can sort some stuff out. All right, thanks, guys, and we'll see you later.